To continue our discussions on the hyperbolas, we have another two problems here. The first one, we are asked to find the center and vertices of this hyperbola and sketch the graph. No? And the given equation for the hyperbola that we are going to consider is 4y squared minus 9x squared is equal to 36. So this is the polynomial form of the hyperbolas. We're going to transform this into the standard form of the hyperbola. No? So we divide both sides of the equation by 36. By doing that, we get this form, no? 4y squared over 36 minus 9x squared over 36 is equal to 1. And then we're going to reduce this into smallest term. No? So we get y squared over 9 minus x squared over 4 is equal to 1. So as you can see, we have reduced the given equation of this equation here to the standard form of the hyperbolas in the form of this, no? Y squared over a squared minus x squared over b squared is equal to 1. Where a squared is equal to 9 and b squared is equal to 4. No? And since we have this form, no, there's no h and k for the vertex, no. For the center. The center of this hyperbola is the origin, no? With coordinates 0, 0. So knowing this, no, knowing this form here, as you can see, y squared is positive, no? Which means that the transverse axis of this hyperbola is along the y-axis, no? This center here along the y-axis. So we're going to look for the coordinates of the vertices, no? The main vertices has this form 0, comma, plus or minus a, no? So a squared is 9, so a is square root of 9, which is plus or minus positive 3, no? So plus or minus positive 3 is the coordinates of the vertices of the plus or minus positive 3 is, we have this by 2's, no? Proportion by 2, 4, 2, 4, 6, 8, 10, no? By 2 siya, no? 2, 4, 6, 8, and 10, no? So since we know 0 plus or minus 3 of the coordinates of the vertices, the positive vertex is 3, no? This is 2 and this is 4. So this is 3, no? Here. And the negative 3 is 2 and this is 4 and this is 3. So this is the vertices, no? Positive, negative 3. And the coordinates of the co vertices are plus or minus b0, no? So b here, as you can see, is 4, no? B squared is 4. So b is plus or minus 2, no? The square root of square root of 4, no? Plus or minus 2, 0, no? Plus or minus 2, 0. So to locate this one, this is 2, no? This is 2, and this is negative 2. So we just make an imaginary triangle here, rectangle here, and then we connect so as to guide our sketch of the hyperbola. We connect the diagonal from point to point, and the positive one is from this line here. Now, as you can see, the center is 0, and this is a vertices plus or minus 3, and this one is 2 and 2, no? 2 and negative 2. So this is the co vertices. So the coordinates of the foci, no, is along, since this is the transverse axis is the y-axis, the foci is 0 plus or minus c. where C is the square root of A squared plus B squared. We just add A squared, no? A squared, just add 9 and 4, which is 13. The square root of 13, this is plus or minus square root of 13 is, so we get a foci with the coordinates 0 plus or minus 3.6. So the foci here is along positive 3.6, no? And negative 3.6. And then this curve here for the hyperbola, no, will somewhat is approaching these asymptotes here, no? So these asymptotes here, the equation of the asymptotes here is y, and the slope of the asymptotes here are plus or minus a over b x, no? So this is our equation of the asymptotes. So we have another problem here, second problem here of the hyperbolas. We are asked again to locate, no, the center, vertices, foci, and we're going to draw the asymptotes and trace the curve. The given problem here states that is x minus 1 quantity squared over 16 minus y minus 2 quantity squared, I mean y minus 2 quantity squared over 9 is equal to 1. So we have the values of h and k for the center, which is 1 and 2, no? So since the standard form of the hyperbola is x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1, no? So the center is h and k, no? Knowing this, no, we're just going to compare the standard form of this hyperbola here to the given problem here, no? The a squared is 16 and b squared is equal to 9. So the coordinates of the vertices is, r is plus or minus a, k, no? So since this hyperbola, the center of this hyperbola is not the origin, no? It's not the origin of the rectangular coordinates. So the center are 1, which is the value of h here, no? Plus or minus a. A is 16, no? A squared is 16. The square root of that is plus or minus 4, 2, no? 2 is the value of k, no? So which means that the coordinates of the vertices are 5, 2 and negative 3, 2. So we locate that along on our rectangular coordinates here. The center is 1 and 2, no? This is by 2 again, no? 2, 4, 6, 8, 10, and this one is 2, 4, 6, 8, 10. No? So 1 and 2 is somewhere here, and then go up 2, no? This is our center, no? And the vertices is negative 3 plus or minus, the vertices are 5 and 2, this is 5, 2, 4, 5, and then 2, and negative 3, this is negative 3, and 2. And the coordinates of the co vertices are h, no, comma, k plus b. So h, k plus b. No? So this is 1, the value of our h is 1, and 2 plus or minus 3. No? The value of b is plus or minus 3. No? So this is our b. No? The square root of 9 is 3. No? So we have here the co vertices are 1, 2 plus 3 is 5, and 1, comma, negative 1. So we locate that on our, we locate this one, the Co Vertices, along our rectangular coordinates. No? 1 and 5, no? 1 and this one is 5, and 1 and so 1 and 5, and 1 and negative 1, and 1 and negative 1. And then we connect all the vertices. We will have this rectangular form here, and then we connect the diagonals, this point here, no, to this point, and we get the, we have here our vertices, no? So the focus now will be, the foci are h plus or minus c plus k, no? Where the value of c is square root of a squared plus b squared. We have a squared to be numbers. A squared is 16 and b squared is 9. We just add that, no? A squared is 16 plus 9, square root of 25 is plus or minus 5. So the value now of the foci are 1 plus or minus 5, comma 2, or 1 plus 5 is 6, and 1 minus 5 is negative 4, with the same value for k, which is 2, no? So we have here 6 and 2 and 4 and 2. We locate for the value on the, we locate for the foci, we have here 2, 4, 6, and 2, and negative 4, this is our negative 4, no? Negative 4, 2, 4, and 2, no? So we connect, no? And then we draw a curve approaching the asymptotes, no? The asymptotes will be plus or minus b over a, no? The slope of this one, no? B over a. B is, as you have said, B is 3, and a is equal to 4, no? Square root of 16 is 4. So the asymptotes will be b over a, x minus h, plus 2, no? So we have here 3, 4, the slope, and x minus 1 plus 2, no? Value of the, this is the equation for this asymptotes here, no? For the asymptotes. So that's it, no? That's how we're going to draw a curve, no? Having known the center, the vertices, and the foci. So we're going to use these asymptotes here, the values of the two asymptotes, to guide us in drawing or sketching the curve of the hyperbolas. So thank you for watching again our videos. Please subscribe to my YouTube channel by Fred Tan, and also if you have some comments and suggestions, please send it to us so that we can improve our way of presentation. And also, please send the comments and suggestions in English form or Tagalog. No? So thank you again, and see you again later. Bye-bye.